At 100 hours along a stretch of Venezuelan coastline near Puerto Cabo, a facility that officially did not exist was running at full operational capacity. 200 meters of reinforced concrete dock, 1 meter thick, the kind of construction spec that isn't chosen for civilian maritime use. Beneath it, buried in bedrock and shielded by the chaotic geography of the Venezuelan coast, a subterranean complex housing satellite, uplinks, processing laboratories, and enough product to move 500 kilograms of cocaine per week into distribution networks that stretched across 3 continents. The Tren de Aragua cartel had spent 2 years and an estimated $1 billion building what their commanders considered untouchable. They were wrong by approximately 4 Hellfire missiles. The facility was not just a logistics hub. It was a statement, a physical assertion that Maduro's government, shielded by Russian-supplied air defense systems and the implicit protection of diplomatic relationships with Moscow, had created a zone in the Caribbean where American reach did not extend. To protect that assertion, the cartel had deployed Colchuga NE passive radar systems along the coastal approaches. Unlike conventional radar, the Colchuga does not broadcast. It listens, harvesting the electronic emissions of approaching aircraft, ships, and drones from up to 600 kilometers away without ever revealing its own position through transmitted signals. Venezuelan operators running these systems believed they had created an early warning envelope that made surprise attack from the sea or low altitude impossible. They had accounted for every threat vector except one, directly overhead. At 50,000 feet, well above the Colchuga's effective detection cone, which narrows to a blind spot at high elevation angles directly above the receiver. A CIAMQ-9 Reaper had been holding station for hours. The Reaper's altitude kept it outside the passive radar's functional geometry. From that position, its sensors were generating a thermal and signals intelligence map of the facility below with a resolution that ground-based intelligence collection could not replicate. The cartel's cooling systems, running continuously to manage heat loads in the subterranean complex, produced a thermal signature that bled through the ventilation architecture and registered clearly against the ambient temperature of the surrounding rock. 150 nautical miles offshore, an Arleigh Burke-class destroyer was operating under MCON Phase 3. Emissions control, the naval discipline of making a billion-dollar warship electronically invisible. The AN/SPY-6 phased array radar, offline. Active sonar, passive mode only. Radio transmissions secured to minimum essential communications on low probability of intercept waveforms. To the Colchuga operators scanning the horizon, the destroyer's electronic profile looked like open ocean. What the destroyer's passive systems were doing, however, was anything but passive. The AN/SLQ-32 V6 electronic warfare suite was conducting a full spectral mapping of the coastal defense architecture, cataloging every radar frequency, every communication uplink, every electronic system the facility and its protective envelope were operating. This is the intelligence collection mission that precedes a strike. Not just finding the target, but understanding every layer of detection and response between the launch platform and the impact point. The Aegis Combat Management System was processing all of it. What it found changed the mission profile entirely. Buried beneath the thermal signature of the cooling systems, Aegis's signal processing architecture isolated a low-frequency electromagnetic hum emanating from deep below the concrete dock surface. The frequency range and pattern were inconsistent with dock infrastructure. They matched the harmonic signature of high-capacity satellite communication hardware, the kind used for encrypted operational coordination, not port management. The 200-meter reinforced concrete dock was not the target. It was the decoy. The real operational center was underground, and the dock above it was engineered to absorb American ordnance, while the true facility survived intact beneath the bedrock. The cartel's advisors had designed a trap. American missiles would hit the surface, the dock would absorb the damage, satellite imagery would show a destroyed facility, and the subterranean infrastructure would resume operations within days. The Aegis system had just read the trap from 150 nautical miles away. At 0130, the SLQ-32 shifted from collection to active electronic shaping. Rather than jamming the coastal radar systems, an action that would have created an obvious gap on Venezuelan operator screens and triggered an alert, the system began injecting modified sea clutter returns into the Colchuga receivers. The sensors continued displaying what appeared to be a normal environmental picture. Ocean surface returns, ambient atmospheric scatter, routine background noise. The approaching threat corridor looked on every Venezuelan screen like empty coastline. The digital picture was a construction. The coastline was not empty. Under the surface, two Yugo-class midget submarines, compact, cold-running vessels capable of carrying torpedoes and manned by operators whose organizational affiliation was difficult to formally establish, were running patrol patterns through the deep water channels approaching the dock. These are not sophisticated platforms by modern naval standards, but sophistication is not their operational requirement. A single test 71 wire-guided torpedo from a vessel that registers as almost nothing on active sonar is an existential threat to a surface combatant in shallow littoral water, and the operational geometry forced the destroyer to manage that threat while simultaneously coordinating the strike package overhead. The towed array sonar picked up the propeller signature at 20 kilometers. Faint, periodic, consistent with a diesel-electric vessel running on battery power at minimum revolutions. The solution chosen was not kinetic. A torpedo launch in those waters would have produced an acoustic event detectable across the region. A detonation that would alert every Venezuelan military asset within range that an American strike was underway and collapse the electronic deception the SLQ-32 was maintaining. Instead, the destroyer's acoustic systems generated a false sonar return. A synthetic contact placed 5 nautical miles seaward of the mini-submarine's patrol track, bearing the acoustic characteristics of a surface vessel maneuvering away from the coast. Both submarines altered course to investigate. The real approach corridor opened. At 0145, a Russian-origin cyber attack targeted the destroyer's network infrastructure. Attribution analysis conducted later identified the intrusion attempt as bearing the signatures of a unit with documented ties to Russian state cyber operations. Cozy Bear methodology applied to military network penetration, aimed at corrupting the Aegis fire control architecture during the 10-minute window that would have been required for Venezuelan Su-30 flankers to scramble and reach engagement range. The intent was to blind the destroyer's defensive systems at the moment of maximum vulnerability. The malware contacted the network perimeter and was quarantined within seconds. The Aegis cybersecurity architecture is not a passive firewall. It is an active detection and isolation system that identified the intrusion signature, contained it to a sandboxed environment, and generated a return signal along the originating communication pathway that corrupted the satellite uplink the attack had transited. The cartel's encrypted communications infrastructure, the same uplink system the Kolchuga operators were using to coordinate with air defense batteries, went dark. Venezuelan air defense operators were now managing their systems with degraded communications, chasing a clean electronic picture that was a fiction, and had no awareness that anything had changed. By 0210, the operational corridor was confirmed clear. The MQ-9 Reaper descended from 50,000 feet to 500 feet, low enough to hide in the radar ground clutter generated by the wave surface, invisible to systems that were already looking at a manipulated picture. The transition from strategic altitude to attack profile took the aircraft through an altitude band that would normally be visible to a functioning coastal radar network. None of the Venezuelan systems were seeing accurately enough to register it. At 0215, an MH-60R Romeo helicopter, which had been holding position below the jungle tree line since before the destroyer arrived on station, activated its multi-mode targeting system and designated the ventilation shaft. The laser spot it placed on that 50-centimeter opening in the rock face was a coordinate with a specific meaning, not the decoy, the real target. 4 AGM-114R Romeo Hellfire missiles separated from the Reaper's pylons in sequence. The AGM-114R is a dual warhead precision strike munition 1.63 meters long, 49 kilograms at launch, with a shaped charge and blast fragmentation warhead optimized for hardened structures. It reaches Mach 1.3 in terminal flight and receives mid-course guidance updates via data link throughout its engagement, meaning the Reaper's point of launch does not determine the point of impact. The Aegis system via Link 16 was feeding updated targeting coordinates to each missile in flight, refining their impact solutions as the Romeo's laser designation tracked the facility's specific structural vulnerabilities. Missiles 1, 2, and 3 impacted the reinforced concrete dock surface across a 40-meter spread pattern. 1 meter of reinforced concrete absorbs enormous amounts of kinetic energy, and the cartel's engineers had calculated those tolerances correctly. The dock took the hits. The fireball visible from the surface was exactly what the facility's designers had hoped an American strike would produce. A dramatic, photogenic destruction of a decoy that left the real infrastructure untouched. The fourth missile did not go to the dock. It tracked the Romeo's laser designation to the ventilation shaft. The shaft was 50 centimeters in diameter. the Hellfire's guidance tolerance in terminal phase is measured in centimeters. The missile entered the shaft and detonated at depth inside the rock below the reinforced ceiling of the subterranean complex. A confined detonation inside an underground structure does not produce a surface fireball. It produces a pressure wave that has nowhere to go except into the surrounding architecture. The subterranean complex experienced a structural implosion, ceiling sections, internal walls, and equipment racks collapsing inward as the overpressure pulse propagated through the enclosed space. The satellite uplink hardware, the processing laboratory, the 100-ton product inventory, and the coordination infrastructure the cartel had spent 2 years building were buried under their own foundation. The muffled detonation registered on seismic sensors. On the surface, the dock was already a burning debris field. Below it, where the real operation had been running, there was now rubble. The MQ-9 Reaper was already 40 kilometers out over open water when Venezuelan military commanders began processing what had happened. Had the Venezuelan Su-30MK two flankers scrambled during any phase of the operation, the engagement geometry was already computed. The Arleigh Burke's AN/AAQ 37 infrared search and track system can acquire a jet engine's thermal signature at 200 kilometers, without emitting a single radar pulse, without revealing the destroyer's position, without triggering the flanker pilot's radar warning receiver. An SM-6 Block 2A interceptor, climbing at Mach 3.5 toward an intercept point, calculated by Aegis before the Su-30 pilot had finished his pre-launch checklist, would have reached engagement parameters before any Venezuelan air-to-air weapon could be armed. The flankers never launched. But the solution was ready. The cost accounting of this operation is instructive. The cartel's total investment in the facility, an estimated $1 billion in construction, equipment, Russian-sourced sensor systems, and the 2-year operational period that preceded the strike. The American expenditure, 4 Hellfire missiles at approximately $150,000 each, helicopter and drone operational costs for a single mission cycle, and the electronic warfare and data link resources of a destroyer that was already on patrol in the region. $600,000 in munitions against $1 billion target. The intelligence return exceeds the kinetic result. Every Kolchuga NE operating frequency, every cartel satellite uplink encryption parameter, every acoustic signature from the Yugo-class submarines, and the complete methodology of the cyber attack conducted against the destroyer's network are now in American systems for exploitation, analysis, and future planning. The cartel revealed its full defensive architecture during its final operational hours, and every piece of that revelation was collected. Maduro's calculation that Russian-supplied sensors and $1 billion of reinforced concrete could create a zone beyond American reach in the Caribbean met the specific system architecture that was designed to defeat exactly that combination. Passive radar that doesn't broadcast has a cone of silence directly above it. Underground facilities that need ventilation have thermal signatures. Decoy structures that are built to absorb strikes still need to house the real infrastructure somewhere. Submarines running on battery power still have propellers. Every defensive measure the cartel deployed had a corresponding sensor or countermeasure in the American system that the cartel's advisors either did not know about or chose to discount. The Caribbean coastline near Puerto Cabo is quieter now. The satellite uplinks that were broadcasting encrypted coordination traffic are offline under rubble. The dock that was supposed to be the last word in protected infrastructure is a debris field. The Tren de Aragua's engineers built a facility they believed was invisible. The Aegis system found it by listening to the sound of its own cooling fans. Modern precision strike is not primarily about missiles. It is about the information architecture that surrounds them. The network of sensors, processors, and data links that converts a target's own electronic emissions into a coordinate, and a coordinate into a result. The cartel brought hardened concrete and passive radar to a contest where the opposing side was reading their thermal signature from 50,000 feet before the operation ever began. Which element of the strike architecture do you think was the decisive factor? The Kolchuga's vertical blind spot that allowed the Reaper to hold position undetected, or the Aegis ELINT capability that identified the ventilation shaft as the real target while the decoy dock was still standing? Tell us in the comments. And if you want more analysis of precision strike operations and the sensor networks that make them possible, subscribe and hit the notification bell.